welcome to the Explainer. Today, we're jumping right into Cisco's SD WAN solution. We're going to focus on two big things: its security architecture and the actual hardware that makes it all run. These days, the network is the business, right? So figuring out how to lock it down is absolutely critical. We're going to break down everything you need to know, from the big picture ideas all the way down to what specific boxes can do.
All right, so here's what we've got on tap. First, we're going to talk about why SD-WAN even exists. What was the big problem with traditional WAN security? Then, we'll look at the 3 modern ways Cisco tackles that problem. After that, we'll get our hands dirty with the hardware, checking out the different platform families, and even comparing some popular branch routers head-to-head. And to wrap it all up, we'll get super practical and see exactly which security features you can run on which pieces of kit. Super important stuff if you're designing these networks.
Okay, first things first. To really get why SD-WAN is such a big deal, we've got to go back in time a little. We need to understand the problem it was built to solve. So let's set the stage. Let's look at the old school WAN model and figure out why this thing that worked for so long is just, well, creaking under the pressure of today's cloud-heavy world.
So this right here, this is the classic hub-and-spoke model. And for decades, this setup made total sense. The corporate data center was king. It was the center of the universe, because that's where all the important stuff lived. All the apps, all the data. So it didn't matter if you were in a branch office in Topeka or London, your traffic, all of it, got funneled back to that central data center for all its security checks. But then, everything changed. The cloud happened, right? Suddenly we have all these SaaS apps like Microsoft 365, and we're using cloud platforms like AWS. The whole center of gravity shifted from our private data center out to the internet. And trying to force all that internet-bound traffic to take a long detour back to headquarters, well, it creates this insane traffic jam. We call it tromboning, and it's just a terrible, inefficient way to do things. It adds a ton of delay, and honestly, the user experience stinks, especially when you're on a Zoom call and everything starts to lag.
And securing that one central exit point was a beast of a job. You had this whole stack of expensive boxes. You needed your firewall, your IPS to stop attacks, your web filters. You even needed special hardware just to look inside encrypted traffic. It was like building this giant, complicated tower of security pier. And it wasn't just slow, it was a nightmare to manage. Think about all the patching, the troubleshooting, and trying to make it bigger as your company grew. Forget about it.
So clearly, something had to give. A whole new way of thinking about security was needed, one that could actually handle traffic going everywhere, especially to the cloud. And that's where Cisco SD-WAN comes in. It gives you 3 really flexible ways to build your network security, and each one is designed for a different kind of need.
Okay, model number 1 is what we call integrated security. You can think of it as the thick branch model. The whole idea is simple. Instead of sending traffic way back to a central office, why not just put the entire security stack right in the branch? So you get one powerful box that does all the routing, the firewalling, the IPS, the whole shebang. This means your branch gets a direct, super fast, and secure pipe to the internet. Performance for cloud apps goes way up, and you're still totally protected. Now, the second option is more of a middle ground, a hybrid approach. You're still centralizing your security, but you're not sending traffic all the way back to the main data center. Instead, you set up these smaller regional security hubs in places like co-location facilities. These hubs are way closer to your actual users, so a branch in California sends its traffic to a hub in, say, Los Angeles, instead of all the way to New York. It's a really nice balance. You still get that central control, but you slash the latency big time.
And this brings us to option number 3, the most modern approach of all. Just let the cloud handle security. This is what we call the thin branch model, and it's a huge piece of what people are talking about with SASE, or Secure Access Service Edge. With this setup, the box you put in the branch is pretty simple. Its main job is just to get you connected. All the heavy lifting for security, the web filtering, the firewall, all of it is done by a cloud service like Cisco Umbrella. The big win here? It's massively scalable, and your users get the same great protection whether they're in the office or at a coffee shop.
All right, so we've seen the big picture strategies. Now it's time to talk about the tools for the job. Let's dig into the actual hardware, the physical and virtual boxes that make all these designs a reality. Because you can have the best strategy in the world, but you still need the right gear to pull it off.
This here is a great map of the whole SD-WAN Edge portfolio. Cisco has broken it down into 3 main buckets, which pretty much cover any situation you can think of.
You've got your branch gear for your offices, aggregation platforms for the big sites like your data center, and cloud platforms for when you're deploying in places like AWS or Azure.
So let's drill down a little. In the branch, you've got a whole range of options, from the ISR 1000s and 4000s to the newer Catalyst 8200s and 8300s. These can handle anything from a tiny home office to a massive branch. For the big aggregation sites, the real workhorses are the ASR 1000 and the beastly Catalyst 8500. These things are built to handle thousands of connections. And then for the cloud, you've got virtual routers like the CSR 1000V and Catalyst 8000V that you can spin up right inside AWS or Azure to bring your cloud environments right into your network fabric.
You know, we should probably spend a second on the Catalyst 8000 family. These things are a really big deal. They're not just a slightly faster version of the old routers. Nope. They were designed completely from the ground up specifically for SD-WAN and SASE. They've got new custom processors for better performance, they're built to tie in tightly with cloud security, and they can even run other services right on the box at the edge.
Okay, let's zoom in on the branch for a minute, because this is where most of the action is. And picking the right platform here is, well, it's everything. So let's get really specific and put two super popular platforms for smaller branches side by side. The standard ISR 1000 series versus the special ISR 1100 4G and 6G models.
Now here's where it gets interesting. These routers might have similar names, but don't let that fool you. Under the hood, they are completely different beasts, built on different technology and meant for totally different jobs. And you really need to understand these differences because picking the wrong one can be a very expensive mistake.
The biggest difference, the real game changer, is the chip inside. The standard ISR 1000 runs on a normal x86 processor, kind of like your laptop, which makes it really flexible. But the 1100 models? They use a custom ARM processor that is an absolute powerhouse. And this has a huge impact on performance. We're talking about the number of secure tunnels it can handle. The standard box tops out around 200. The ARM-based 1100, it can handle 1,500 tunnels. That's a massive difference. It makes the 1100 perfect for huge rollouts, like for a retail company with thousands of stores.
So the bottom line is you have to match the box to the job. Are you slowly upgrading your old network and need flexibility? Then the standard ISR 1000 is probably your go-to. Are you starting fresh with a massive new network and need as much scale as you can get? Then the ISR 1100 is a no-brainer. And hey, if you just need more physical ports to plug things into, well, that's another reason to look at the 1100 or even step up to a Catalyst 8200.
Okay, time to bring this all home. We've talked strategy, we've talked hardware. Now for the final piece of the puzzle. Let's map the actual security features to the platforms that can run them. This is where the rubber meets the road, folks. So here's the million-dollar question for any network designer. What can my box actually do? You have to know the capabilities, but just as important, you have to know the limitations of the hardware you're choosing. Because when it comes to running security on the box itself, not all platforms are the same. And getting this wrong, well, it can really mess up your budget and your security.
This chart pretty much tells the whole story. So first, look at the software column. You'll see that all the cool advanced security stuff like the application firewall and IPS, that's only on the newer iOS XE software. Okay, now look at the hardware. Even with iOS XE, the really heavy-duty features like IPS and malware protection, they need more powerful boxes. We're talking about the ISR 1000X, the 4000s, and the Catalyst 8000s. And the biggest resource hog of all, decrypting TLS traffic, is only for the top-of-the-line stuff. But notice, things that rely on the cloud, like Umbrella integration, that works on everything because the cloud is doing all the work.
And here's one last really critical thing to remember. There is no free lunch. When you start turning on all these fancy security features right on the router, it takes a toll. It eats up CPU, it eats up memory, and that means the router's overall speed, its throughput, is going to go down. It's a trade-off, right? Convenience versus raw performance. You just have to make sure you buy a box that's powerful enough to do the job with all the security features you need turned on. So when you boil it all down, moving to SD-WAN isn't just about changing how you do routing. It's way bigger than that. It really forces you to completely rethink your entire approach to security. Your apps are everywhere, your users are everywhere, so your security has to be everywhere too. It has to move beyond that old-school castle wall and become something smarter, more flexible, and built for the cloud. That's our explainer for today.